welcome to Tech with Sas. In this video, I will not talk about any technical concept or any architectural pattern like I normally do, but I will talk about a dilemma faced by the software engineers, right? So, whenever we gain some years of experience, right, as a software engineer, then we think, okay, in my career, like where do I need to move? I mean, where should be my path, right, in my career? So normally we are given, or like we have two choices. I mean, there might be other choices as well, but the major choices which we have, either go into management or become a software architect, right? So now people who choose the or who aspire to become software architect, now biggest question comes, right, how to become a software architect, or even before, what to study for that, right? Because there is no fixed course for a software architect. I mean, there are many courses in the market, but there is no fixed like a syllabus, right? Like we learn Java programming, so we go and learn core Java, advanced Java, Spring, and whatnot, and become a good software engineer in Java technology. But once you want to become a software architect, you go beyond the boundaries of the languages or platforms, right? Because in one project there might be multiple flavors of technologies, multiple platforms are there. So sometime it becomes to become like it might be a technology agnostic sometime, right? So you have to be understanding other concept like which are important as well. So now once, like, I also face this dilemma, right, like what to study to become a software architect. Because uh, I mean, once you aspire about something, right, then you have to work for that. I mean, you cannot get it something just because you are aspiring for it, right? So you have to the prepare for it. So I have prepared. I mean, I have like a very my way, or might be the way I progressed in my software architecture career, like being a Java developer and also worked as a mainframe developer, right, in the past. So what I tried to learn, because there was no fixed path. I was learning from YouTube, from the various courses from online, and also from my seniors by observing them. So maybe the list I'm sharing with you, it not be a complete list, might be very small piece of whole a big aspect of various topics, but it will give you that a good start if you are clueless what to study. So let's deep dive, like what to study, at least to become to do a journey towards becoming architect, right? So here I prepared a mind map, right? I mean, the flow diagram where you can see various topics I have put in. There is no particular order in which you have to follow. Might be there are many things you already know. Okay, so let's go see and each and every topic, like what we want to become, right? How to become software architect, right? So I mean, the first point I have put, right, because this is very important. Because see, uh, be a good developer in at least one technology, right? Because being a software architect, right, you might be involved in multiple technological projects. Might be one project you are doing in Java, another in .NET, maybe another in mainframe or MuleSoft, right? But if you know about one programming language or one technology in a good depth, right? So all technologies, believe or not, are similar, right? They might have different syntax, different way of working, but ultimately they have the same kind of flavor, right? So suppose you understand one technology, so it is really, I mean, it is very easy to change the gears and also focus on other aspect of technology, right? So try to become a good developer before in one technology before you embark a journey to become an architect, right? It can be any technology of your choice, right? Maybe Java, .NET, whatever, right? And second point to remember in your, like, always, that cover more breadth than depth, right? So see, we have time which is limited. We cannot go in each topic in a very deep, right? Maybe, for example, you are a master of Java technology or some technology, so you go inside in depth, right? You know everything, almost everything of that. But if you now working on Python or some project like where you won't code, right? But at least you should know what is happening, what developers are working and what they are doing. Because sometimes, being an architect, there are expectations from developers to help them in some issues, right? So you try to cover various aspects of project, right? So for example, in typical project, we have a UI, might be have some idea about the how UI works, and maybe have some lessons learned about the Angular or React, whatever case may be in your project. And also middleware might be Spring Boot or whatever. So try to understand the various aspect. Like for example, DevOps, right? DevOps is also a aspect of the project. You should understand, because when you talk to DevOps guy, right, you should know their language, right? And suppose there's a database guy, the DB admin. So when you want to talk to him or her, you should know the language, like what keyword you should know. So my point is that the various aspect, like deployment and the programming, front end, back end, database, production support as well, right? Monitoring, okay, resiliency, all those aspects. Maybe you're not the expert, you don't need to go in depth of in every topic, but you should at least know about what is there, right? So that is very important. And third point is really obvious. It is obvious for every field, but being an architect, right, maybe on Friday you get a project, okay, we have a new project coming in AI ML, and you are clueless about AI ML, right? So what you do? So during weekend or sometime when you get from office of hours, right? You learn about it, right? Whatever technology you have been posed to, you have to learn about it. I'm not saying go into depth, learn the coding, but at least learn the higher level architecture. What are various components of it, how they interact with each other. That is the work of architect to understand, right? So always learn continuously, be ahead of the curve, right? So you, because being an architect, you might be going in various meetings where you understand, okay, there's some project coming in this technology, I mean blockchain, right, in future. So be ahead of the curve, right? Read something which might not be useful maybe immediate future, but it might be useful in the coming future, right? So you should always keep learning, keep learning, keep learning. That is the only mantra which is really important to succeed in become architect, right? Now let's come on the concrete things, right? So what to study? So these 3 points which I gave you, they are just a generic point which we should be having in our mind always. So design patterns are definitely important. Might be they are required to become a good programmer, but sometime once you have idea about these design patterns, like we have this creational, structural, behavioral patterns, right? I mean, there's a long list of patterns like singleton, factory patterns. So those you should go know about them in depth, right? Because those patterns apply to all languages, right? So when you are proposing some solution, you can keep thinking about those patterns, because what problem you are solving, right? You are solving it not for just once, right? So you create one pattern, right? So the pattern is pattern you can create when you have idea about in general. Okay, so if you just solve problem just by some crook, right? It won't happen in long. I mean, you can't be good architect, right? So learn the patterns, how patterns evolve, how what are the various aspects of it. Very, very important, right? Then there are like various architecture patterns, like how we organize our applications. So applications might be having the layered architecture, right? Like we have the presentation layer, middle layer, okay, a DB layer, right? All those are there, but understand various aspect of that layer architecture. What are the anti patterns of that? Okay, so when we should use the architecture, I mean this pattern, because see we have event driven also. So when we use event driven, right? When we require the some events to be processed right asynchronously, so you should understand the various architectures like microkernel, monolith, microservices, very important, space-based, service-based. Okay, you should know about these architecture patterns. When you study them, just think, okay, why we need and when we need, right? Because one solution cannot be applied everywhere. So once you understand the nitty-gritty of the architectural pattern and benefits and drawbacks of it, then you can apply at appropriate place, right? Also understand what are the anti-pattern, right? So like when you are using a pattern, whether it is useful or not. So understanding various aspect of the patterns around architecture is really important. Now, once like we have an application, right? There will be integrations happening, because application will be something like you have one component, maybe in MuleSoft. One is in mainframe, okay. Another maybe some queues, Java, right? So how we integrate various platforms, so that aspect also should be known to us. Like for example, we use the Spring integration, right? We have IBM MQ, Apache Kafka for the asynchronous transactions, where we have a PubSub model, right? We have the uh, software AGs, web methods, Apache Camel, MuleSoft, right? So these are various integration patterns or tools. So I'm not saying that you go and learn each and every this topic by heart, but at least understand the various components of them, how they work at high level, right? So because being an architect, you are not supposed to code much. I mean, you code, like you do some POCs, but normally you are asked to give directions or guidelines or standards, right? So when you have idea about the integration patterns, you are able to provide the guidance to the team, right? So now let's see like some other original component which are like always applicable, right? So in any application, you have to see the caching aspect. See, caching is very good, but do we require caching? Okay, do we have such kind of a user base where we need caching? So applying something is very good, but whether we need it or if you need it at what level? Okay, so various patterns about caching, right? So you have to understand the caching concept. You have to understand scaling, because whenever you develop an application, you should know, okay, might be my application is become very popular in future. There will be a lot of users coming, so I have to understand scaling as well. Load balancing is very important, because how to balance the traffic coming from the users to your various containers or the servers. So I mean, these are just topic name are okay, because in my channel you can find the various videos about these topics. So I have covered them in depth. So also the hashing concept, the consistent hashing, cap, Packlek theorem. Okay, all these are really important to distribute the traffic, or make a trade-off between the consistency, availability. Okay, all those things. So these are like few more topics you should consider learning. Async pattern, right? Because we have maybe application having a real-time application where user want response right away. Some batch applications, but there are some applications where we have loose coupling, like we have asynchronous pattern where event can be processed later, maybe after some time, right? So understand the async pattern, queue concept, right? PubSub model. Okay, API is really important. Now API is a buzzword in the industry. So API concept, REST concept, right? So how REST resource is defined. So difference between the verb-based URLs and the resource-based URLs is really important to understand, become a good architect. Then definitely in the backend you have either SQL, NoSQL. So understand the basics of that. And DB performance, sometime there will be SLA issues, right? So your applications are performing well, so you have to understand the problem. Maybe you have to also know about something about database performance and sharding, right? Then once you build application, right, you want to make application which is resilience and fault tolerance, so it is able to absorb the issues seamlessly. So understand the concept of resiliency, fault tolerance, understand like pattern like a circuit breaker, rate limiter, sidecar pattern. Okay, so all these patterns, I'm just giving some names, right? The big list of patterns, I am not putting it everything here, but these are just indicative list to you. Then normally nowadays projects are moving to microservices from monolith. Understand the ways the patterns around like strangler pattern, anti-corruption layer, right? So there are various patterns about it. Understand about them. Solid principles, acid principles, right? So these are also really important to understand, become architect too, because you have a higher understanding once you know about all these things, right? And then the very important aspect is security. App security is really important. How SLS, SSL, TLS work, how we can use the Kerberos based auth pattern like OAuth, jailability. So all those concepts are really important. So this is like some indicative list. So I will also provide a link in my video description. But if you are really starting to become architect, thinking about it, so this can be a very good starter to at least start reading something from YouTube. I have also a few of my videos about these topics. You can learn from there. Any question if you have regarding the journey to become architect, you can ping me on the comment box. I will try to resolve them. And might be in future I'll try to enhance this list so that you get more topics, right? So I think this will be helpful to at least start reading about these concepts. Thank you very much for watching the video. Please subscribe my channel if you like. Thank you very much.